Okay, everybody, welcome back. We're going to go to the next step here, and the next step is going to be how you actually write chemical formulas and naming compounds. So, again, this is going to be something you're going to have to work through. It's a skill you have to acquire. So, definitely take your chance to practice and make sure you're going through it. But we're going to go through it now. Here's something we all know well: ethyl alcohol, right, in your hand sanitizer. So it's important sometimes to know what's in a chemical formula, and the first step we want to do is how you actually write a chemical formula, uh, and that's the important thing. So how do you actually write the formula from the name of a substance? So first step, okay. So the first two things you want to keep in mind when you do this, okay. Number one is you're going to have roughly again, this is most of the time from the simple ones we're going to do. You're going to have a positive element written before a negative element. Okay. And again, those positive and negative elements, if you take a look at them, or a polyatomic ion, and you can use those too if you've been studying them, and you want to be able to take those and put the positive element written before the negative one, and that's going to be a huge thing to remember. All right, so it's basic, but you want to come back to it each time you do that. All right. Next, when you take your positive charges and your negative charges, the sum of those two in any compound must equal zero. All right, so all your positives and all your negatives. So in a correctly made formula of any compound, this is going to be neutral. Okay, and that's going to be important to know. So it's these two rules I want you to keep coming back to, if you have a problem or when you have a problem. Okay, so for example, let's just say I have the compound sodium chloride. It's going to have two different names to it. It's going to have a positive element and a negative element. So you'll see positive, negative. Now, the charges that you see here, you can get from your charges in your periodic table. All right, and it's important to have that periodic table handy that I have in your packet. That will help you find these charges. So you'll always be given these charges. Charges will be on the table for you. So you'd find sodium, find its charge. Find chlorine, chloride, find its charge. Again, it's being written second, so it's going to be the negative element. And just to prove it, that both of them, you'll see, would be plus 1, minus 1 is going to equal 0, and that's why the correct formula for sodium chloride is going to be NaCl. Okay, and notice we write the final formula without the charges. Okay, now if we want to take a look at magnesium and magnesium bromide, we'll see something slightly different. You'll see magnesium is an element that has a plus 2 charge, and bromine is going to have a minus 1 charge, just like chlorine. So, but when you look at this, you notice that it doesn't make 0 the way it is, right? Because this is a plus 2 and a minus 1. So what we're going to need is another bromine to combine to make a negative 2 here, right? When you add these two, you'll have a negative 2, okay? And the negative 2 would then cancel the positive 2, and that's the way this compound forms. So you'll see the 2 and the negative 1 and the negative 1 combine to make the 0. So in order to show the reader that is what you need magnesium and 2 bromides. We then would have MgBr with a 2 here. So that's what that 2 does. That 2 multiplies these guys by 2, or one of them by 2, so that you could be able to cancel the plus 2. So really what we're trying to do is get a neutral charge from the two pieces. All right. If we take it a step further and go to aluminum, we see aluminum is going to have a plus 3. So we're going to need 3 fluorines this time so that we get a minus 3 total, right? So we could cancel out the plus 3. So the plus 3 and the minus 3, those would cancel. And then we would have aluminum fluoride. All right, so this is important to see, is why we see these subscripts in some of these simple compounds is because of the second rule. We want to be able to get the sums to be equal to 0. All right. Now, there's an easy way to. This is the correct, I would say, quote unquote, correct way to do it, because you're really thinking about the number of ions that you need to cancel out the other. However, there's a quick way to do this, and I'm going to show that to you. But I want you to understand why you're doing it. So we're doing this so that we get to 0. The crisscross method is a simple method to get us to 0 very quickly. So what you would do is write the element symbol or the polyatomic ion and their charges. Okay, just like we did here. So you write your symbol and your polyatomic ion or your regular ion with a charge. Okay, and if the charges are the same, okay, so if you have a 3 plus and a 3 minus, or a or a plus and a minus, notice we didn't have to do anything. It just becomes NaCl just as it's written. Okay, and you would just write the formula as is. Okay, if the charges are different, okay, then you're going to crisscross the charges, okay, and remove the plus and minus. All right, and again, in this rule right here, we're going to need some practice with. So I mean, from here, it might not make too much sense to you, but it will when we do a problem. Okay, and we're always going to reduce our formulas to lowest terms. Okay, what do I mean by that? If you have a 2 and a 2, that becomes a 1 and a 1. Just like a fraction. If you had 2 over 4, you would reduce that to 1 over 2, right? Otherwise, your math teacher would probably get mad at you. All right, so that's the way it goes. All right, so let's practice a little bit this crisscross. All right, so let's write the formula for these simple following simple compounds. All right, so if I go to pen, and then I go to my color that I want. Yeah, okay. So if I had potassium oxide, so what I'm going to do with potassium oxide is I'm going to, number one, find my elements. So I find potassium, and I find oxygen. Oxide would be oxygen, all right, in that way. Okay, now it's important to know here that you want to find your charges next. So I go to the table, and I find that potassium is +1, and I have oxygen is -2. Now, interestingly enough, they're not the same, right? It's not a +2 and a -2, or a +3 and a -3, or a +1 and a -1. It's +1 and -2. So in this case, you can't just cancel them. So what I'm going to do is this. I'm going to crisscross the charges. So what I'm going to do, watch really carefully. I'm going to take this 2, and I'm going to move it down over here and make it a subscript. And I'm going to take that 1, and I'm going to move it down here and make that a subscript. And I'm going to rewrite this. So I'm going to have K2O1. Now, we never write ones. So from here on in, I don't want you writing ones down here. In fact, the 1 is up here. Just don't crisscross it. All right? And I'm going to rewrite this without the 1, and the answer will be K2O. Okay, so that becomes the answer. All right? So notice I took the charges, I brought them down, and then there's no more charges at the top. You got to get rid of the numbers at the top. Don't bring them straight down. You got to crisscross them. So see the cross here? There's a cross right in the middle. That's what I want you to see. All right? Whoops. So next, aluminum sulfide. So I'm going to find aluminum. I'm going to find aluminum. I'm going to find sulfide. Okay? And now what I'm going to do is I'm going to find my aluminum charges +3. I'm going to find my sulfur charges -2 from the table now. Now again, some of these charges you can see for sulfur have a lot of different charges. Some of them have more than one type of charge. And if they do, you have to decide which one you're going to use. But because sulfur is written second, you got to use the negative. So sulfur would use the neg charge. Make sure, okay? Now again, these are not the same. They're going to be different. So you want to cancel them now. You want to be able to crisscross them. So the 2 comes down here, 2. The 3 comes down here, 3. Okay? You get rid of the top, right? We're going to get rid of this at the top, get rid of this at the top. Now you write your formula. Al2S3. Awesome, right? So we're doing okay here. All right, sodium carbonate. Let's take a look at sodium carbonate. Now, sodium is going to be +1. Now, this is interesting here because this is a polyatomic ion. And these are the ones you're supposed to memorize, so I hope you memorize them. So if you do, then you know what you're doing. All right, so carbonate is going to be CO3 2-. Okay, so again, remember that this is a group. That's a group here. That stays together. So now the 2 is going to come all the way down here. That. And now you're going to Na2CO3. Okay, so that's going to be that. Very cool. All right. Now, what I want to do is let's fill in this quick chart by crisscrossing. Let's practice here. So let's just say I have NaCl. I'm going to say NaCl. Now, in this instance, we're going to be able to just leave them because it's a +1 -1. So there's no reason to crisscross. We just write the compound NaCl. All right. Let's try calcium and chlorine. We write calcium. Calcium is a 2+. We have chlorine -1. These are different, so we're going to have to crisscross. We're going to bring the 2 down here. We don't bring the 1 down. It becomes calcium. All right. Okay. Fe. Let's go Fe 3 plus, right? And then we have chlorine, which is a -1. Okay, the 3 comes down to the bottom. The 1 does not crisscross. We have Fe Cl3. All right, pretty good. All right, so what if we had something like this? What if we had Na and O2? So again, Na written first. Remember, the positive was written first. And then O2. And then that 2 is going to come down. And we have Na2O. All right. And let's just say we have calcium and oxygen. We have Ca2 plus and O2 minus. And then we're going to crisscross, right? We're going to crisscross these two. Wait, we don't have to crisscross these, do we? Oh, I almost told you a lie. No, we don't have to crisscross these because 2 and 2 just cancel. 2 plus and 2 minus. Remember, we want to make 0. So if these two numbers already make 0, then you don't have to do anything. We're done, right? Okay, what about iron? 3 plus and O2 minus. Okay, so again, we can crisscross these. Put the 2 down here and the 3 down here. And we got Fe2O3. Don't switch them. Okay, that's pretty good. How about these now? You have a polyatomic ion now, so we're going to take Na plus and PO4 3 minus. Okay, so then again, not neutral, so we're not going to bring the 1 down. We're going to take the 3 down here. I'm going to call this Na3 PO4 like that. Sounds pretty good, right? So we're not going to bring the 1. Now here it gets a little interesting. We're going to get a little crazy here. So we have calcium with a 2 plus, and we have a phosphate with a 3 minus. Now here's interesting. 3 minus, you can see it. Interesting. We're going to have to bring it down. So we're going to bring the 3 down here. Now watch this really carefully. So the 3 comes down here. But what are we going to do with this 2? This 2 is going to come down here, but like, what do you do with it? All right, now we got to tell the reader that this is a group. This PO4 is a group. So we're going to get a little funky here, and if you guess parentheses, you guessed it right. So we're going to put PO4 in parentheses here, too. So we can't mess with that family, right? That family has to stay together. So we have to show that it's together by using parentheses multiplied by 2. So the final answer here, if you're trying to make too much of a mess, is Ca3, open parentheses PO4, right? Close parentheses 2. Okay, so that's how that looks. All right, similar here. Very well, watch this story. We have Fe, 3 plus, and then we have PO4, 3 minus. Now, does a 3 minus and a 3 plus make 0? You bet you believe it does. So we don't have to do anything here. Put them together. Fe, PO4. All right, so that's your practice for a little while, and it's kind of a good way to do it. If you have to rewind it and go back and like do this again, I would try to do it again. Okay, again, if I go back a little ways, and I go back to the previous slide, all right, what you really want to remember is these two: positive element before the negative element, or polyatomic ion. Again, you can have a polyatomic ion here. That's important to know too. All right, oops. And make sure the sum of those charges equals 0. You can do it this way. And that's what the crisscross method does. The crisscross method allows you to get them to 0 when you do that. Okay, and that's a really important part of this whole thing. Okay, and lastly, I just want to show you why it's important here. If you see something like potassium oxide, if you take this thing and you go to the pen, and you can see that potassium. Hold on one second, guys. Pen. If you take potassium oxide and you had the K2O, remember that this was a +1, this was a -2. So if you have +1 times 2 is +2, and the -2, that's going to make 0. Okay? So this is the way to see it. I want you guys to be able to see this. Okay? We're going to do a lot of practice, so if you have to rewind this and check it out, check it out. Thank you.